Then interaction. This way we can select 4 manipulated variables to control 4 process variables. These are the manipulated variables selected by qualitative analysis. Next, what is interaction and how it can be analyzed, that we will see now. Already we have seen that if M1 is the manipulated variable and PV1 and PV2 are Y1 and Y2 are Y1 and Y2 are two process variables, means suppose you are controlling Y1 by manipulating M1, means for change in M1, any change in Y2 is called interaction. For that, we can find the mathematical model. 4 mathematical models you can get. That is H11. H11 equal to change in Y1 for change in M1 is called H11. The first one indicates that the suffix, first suffix indicates that output. Second suffix indicates that input. So H11 means for change in M1, what is the change in Y1? If you find the ratio, that is called H11. Change in Y1 with respect to change in M1. For no change in M2, provided that no change in M2 equal to 0. For that, we have to find that is called H11. In the same way, we can find H21 also. H21 means what? Change in Y2 for change in M1, keeping M2 constant. M2 equal to 0. That is called H22. That is also transfer function. This is like disturbance model. This is input-output model because M1 is used as input to control Y1. That's why this is input-output model. Like that, we can think this is like disturbance model because M1 disturbs Y2. M1 destabilizes Y2 or disturbs Y2. That's why it can be considered as disturbance model. Similarly, we can find H22. H22 means what? Change in Y2 for change in M2 by keeping M1 constant. This is called input-output model. Input-output model. Because we are going to use M2 as manipulated variable for Y2. That's why it is input-output model. What is H12? H12 means delta Y1 for change in M2, keeping M1 constant. So this is disturbance model because we are going to use M2 to control Y2, but it affects Y1 also. That's why this is disturbance model. So if you find all these models, we can obtain the mathematical model of MIMO process. This is the mathematical model of MIMO process in terms of SISO process. Each one is SISO. H11 is one SISO. This is one SISO. This is another SISO. Like that. If you consider M1, Y1 as one process, you will get H11. If you consider M1, Y2 as another process, you will get H21. Like that, 4 SISO combination gives the total MIMO process. This is the mathematical model of MIMO process. So you got 4 transfer functions to represent this 2x2 MIMO process, 2 input, 2 output process. You got 4 SISO transfer functions. 4 SISO transfer functions you got. Now, suppose you want to control Y1 means, we are using M1 as the manipulated variable. For that, the controller is GC1. The controller is GC1. We are fed back that Y1 to that controller GC1. Y1 set point is the set point we can control. Suppose there is a change in Y1 because of some disturbances entering into that process. Some disturbances entering into the process. Because of that, let us assume that initially Y1, Y2 are initially Y1 equal to Y1 set point and Y2 is equal to Y2 set point. Y1 is equal to Y1 set point, Y2 equal to Y2 set point. Initially, that time some disturbances entering into the process. That's why Y1 deviates. Therefore, M1 will be manipulated. M1 will be manipulated to stabilize Y1. to stabilize y1. As m1 is manipulated, y2 also will be deviated. Y2 also will be deviated. As y2 is deviated, this is called direct effect of m1. Direct effect of m1 on y2 or direct effect of m1 on y1. These two are direct effects on m1, y1 and y2. This is disturbance like this is IO like input output like control on y1. So now what will happen? Because of y2 is not disturbed by the disturbance, but because of m1, y2 is deviated. As y2 deviates, this GC2 will bring back y2 to its set point. That's why m2 will change. So m2 will change means m2 is to bring back y2 to its set point. Because of that, it will affect y1 also. That is called indirect effect. That is called indirect effect. So two effects are there. One is direct effect. That is m1 as effect on y1. That is direct effect. Another one is flow through this. M1 go to y2. Because of that, y2 deviates. That is fed back to m2. That because of change in y2, m2 deviated. So it changes y1. This is indirect effect. This is indirect effect. In both ways, y2 is affected. One is direct way, another one is indirect way. This indirect way is because of interaction. Because of interaction. Because y1 and y2 are interacting. That's why this y2 is having some deviation because of interaction. Indirect effect. This direct effect is mentioned here. Suppose let us assume that y2 is in open loop. Open loop. Y2 is in open loop. That time, if you control y1, what will happen? This m1 will deviate y1 and y2. That's all. Y1 will be bring back to y1 set point, but y2 it is in open loop. That's why it will be deviated. It will be deviated. That's all. Y2. Only direct effect is here with y1. Another indirect effect is if both loops are closed. Suppose because of disturbance y1 is deviated means m1 is manipulated. Because of that y2 is deviated. As y2 deviated, m2 stabilize y2. Because of that m2 again y1 is deviated. So that is indirect effect. That is called indirect effect of m1 on y1. That is called interaction. That is called interaction. If you consider the open loop model, we can write this equation. What is y1? y1 equal to h11 m1 plus h12 m1 h12 m2. Similarly, y2 can be written as h21 m1 plus h22 m2. This is the equation for y1 and y2. That is mentioned as the first equation. If this is for open loop, if you close them, what is the m1 and m2? We can write the expression for m1, m2. What is m1? M1 is first controller output. What is the set point for first controller output? What is the error in the first controller? y1 set point minus y1. What is m2? m2 equal to g2. GC2, GC, this is GC1, this is GC2, controller 2. For that y2 set point minus y2, we can write like that. This is second equation. If you substitute this in the, for m1, m2, if you substitute this, you will get these two equations. You will get these two equations. If you find the expression for y1 and y2, if you simplify this, and find the expression for y1 and y2, you will get these two expressions. That is 9 and 10. What 9 says? y1 equal to p11 y1 set point plus p12 y2 set point. This is the expression where p11 is in terms of h11, h12, h21, etc. 4 transfer functions. It is function of 4 transfer functions. In the same way, here it is P11, here it is function of P22. P22 also function of all 4 transfer functions. P12 and P21 are functions of again 4 transfer functions. If you see the denominator is this. The denominator of the transfer function is again, it is function of 4 transfer functions. But if no interaction means, what is y1? Y1 equal to y1 by y1 set point. The transfer function, if you find, if no interaction means, what you will get? H11 GC1 upon first 1 plus H11 GC1. That's all. Only H11 is involved if no interaction means. But if interaction is there, all the 4 transfer functions are involved in this. It becomes very complex. That's why there is no guarantee for stability if interaction is there. Suppose I am finding this loop is stable. If I am keeping the second loop, I am keeping loop 2 open. That time I am checking the stability of the loop 1. It is stable. Similarly, I am keeping loop 1 open. Loop 1 open. I am checking the stability of second loop. That is stable. Means if you operate both, there is no guarantee for stability of the system because the denominator is function of all the 4 transfer functions. There is no guarantee that all the poles are the left-hand side of S plane. That's why there is no guarantee for that. That's why while tuning, the tuning problem comes into picture because how you will tune, you will put the second loop open loop and you will tune the first loop first. Then you will put the first loop in open loop, then you will tune the second loop. That way only you can tune. If you tune like that, there is no guarantee that when both loops are operated, the loop will be stable. Both loops will be stable. There is no guarantee. That we can understand from this derivation.